Hello fans of OSG at the Amerimold Show. My name is Alyssa Walther and I'm a product engineer with OSG USA. On our site you'll see 5 videos in which I cover an OSG product common to the mold and die industry. In these presentations I'll be introducing you to the product, features and benefits, target applications, cutting data, as well as product offering. The video you're watching right now will be covering the WXL and the WXS end mill series. So let's get started. First, we're going to start with the WXL end mills. Do you have customers milling non-ferrous materials, cast irons, carbon steels, stainless steels, alloy steels, hardened steels, 35 Rockwell, 45 Rockwell, and up to 55 Rockwell? Well, this is the ideal range for the WXL end mill series. Let's go into some features and benefits of this tool. Low coefficient of friction. So coefficient of friction, we'll talk about this a little bit, but that's basically how slippery the surface is, and it helps with the reduction of BUE, or built up edge. High wear resistance. So this tool is very wear resistant, both in terms of the carbide substrate, how hard the carbide substrate is, as well as the coating that's put on top of it. These end mills are very good with a wide range of work materials, as you saw in the previous slide, from non-ferrous materials, aluminums, all the way up to 50-55 Rockwell hardened material. And it comes in a large offering variety. So you see up here on the screen a square end mill. That's not all we have for the WXL, so we'll get into just exactly what types of tools you can expect from the WXL line. So the WXL coating, so the name of the series is the WXL end mill series, and it's named after the coating that is on these end mills. So while we have a wide variety of different styles of end mills within this series, all of them have this WXL coating. And in comparison to, say, a TiAln based coating, which for OSG we have a blend that is a TiAln base, it's called our EXO coating, you can see the comparison of the WXL with respect to that EXO coating. It's a harder coating. It varies in thickness based on the diameter of the tool, and it has a lower coefficient of friction with a higher oxidation temperature. Oxidation temperature meaning the temperature at which the coating will start to break down. So this tool can last longer in hotter operations, as well as having a more lubricative surface over a standard TiAln type coating. So here we see a graph of the surface hardness, so the hardness of the coating itself versus the oxidation temperature. You see where a standard tin coating would be, a standard TiAln coating would be, and then OSG's EXO coating would be, which I said before is a TiAln base coating. The WXL would fall somewhere around here, so a little north of 3,000 Vickers with a higher oxidation as well. So WXL is one of OSG's premium coatings, which is up there in surface hardness as well as in oxidation temperature. So talking about that low coefficient of friction, so what that means, as I said before, is how it's a measure of how slippery the surface is of the tool. So there are a couple ways to modify that slipperiness. One way is using a coating that has a lower coefficient of friction. So you can see the WXL compared to the WXS, compared to the EXO here, and the lower the coefficient is, the more slippery the surface is. So we said the WXL tools can last and can perform from non-ferrous materials up to hardened materials. So to aid in the non-ferrous materials, or in the lower hardness, the more gummies type stuff, you want to be able to have a coating or something added to the tool that will aid in the reduction of built up edge and the sticking, and to fight the stickiness of those types of materials. So that's why we have this particular coating on these tools. And then high wear resistance. So wear resistance is always critical, especially if you're going to be recommending a tool that is recommended for higher hardness materials. So you can't machine something with a tool that's as hard or not even as hard as what you're trying to machine, right? So you need something that's harder. So the harder that tool is, the more wear resistant it's going to be, and that's especially critical at those higher hardness materials. So in this case, the WXL comes in at about 3100 Vickers. It's not the hardest coating we have, but it's definitely one of the highest. So let's talk about the target applications. So industries that would benefit from tools like this, obviously the dye and mold industry, job shop, automotive. I mean, honestly, because we can recommend this tool for so many materials, as you see in the target work materials chart here, I mean, it's almost like the possibilities are kind of endless, or the target industries are kind of endless because it can be applied in many different types of material. As far as the profile offering, so when I say end profile, I'm talking, is it a square, is it a cornerette, is it a ball, is it a rib processor? So we have all of those with the WXL line. Going a little deeper into that, so here's our square offering. We've got 2 flutes, 4 flutes, a multitude of different lengths of cut and reaches. We have both inch and metric. We've got a lot of square offerings. So as you see, we've got north of 500 different types of sizes and lengths. Here is a full list of all of the square end offering. You see all the list numbers in the first column ranging from 3604 down to 3723, a little description of what each one is. Usually the description will tell you what the length of cut is, 1 times D, 2 times D, 3 times D, etc. And then also the size offering. So we'll go from diameters of a 1/16 up to 3/4 or larger in some cases, or smaller in some cases as well. Here is the full list of all the corner radius tools that we offer. We have 4 different list numbers, all of them with regular length of cut. So usually regular length of cut is somewhere in the ballpark of 2 to 3 times the diameter length of cut with various corner radii, inch or metric. Looking at our ball nose offering, so here we're really shining with the ball nose offering, over 500 different sizes of ball nose tools, inch and metric, with going from stub type lengths up to long overall or long neck type styles as well for those deeper machining operations. And here's a list of all of the ball nose offerings that we have for the WXL list. As you see, we have 3 going from 1/32 in size or 0.01 millimeters up to a 1/2 inch or 20 millimeters. One tool that we would like to pluck out of the WXL series is the WXL EBD and the WXL LN EBD. So again, LN means long neck, and these are highlighted for the precision of the radius. So if you are looking for high precision, highly ground precision cutting tools because your part requires a high precision, or you need to get a very, very, very good surface finish on your part, these are the tools that you're looking to go to. And that's the list 3610, 3710, those are inch and metric, 3690 and 3790 inch and metric as well. The LN EBDs are typically going to be your smaller size, like more of the rib cutter diameters, whereas the WXL EBD are going to be kind of your more quote regular type cutters, so your 6 mils, your 8 mils, your 10 mils, and things of that nature. For the rib processor offering, we've got 2 flutes, we've got 4 flutes, inch and metric sizes, ball nose type rib processors, as well as square size rib processors. Now, as I said, these will be longer. They're rib processors because typically they're in smaller diameters, but their length to diameter ratio as far as reach goes. So the length of cut isn't very long, but the reach is very long. So we see in size dependent, some of these can go up to 30 times D is in reach. We've got 5 different list numbers to choose from for these rib processing tools. They're either pencil neck, rib processors, for ball nose milling or for square end milling. Size ranges are going to vary by list number, usually around a 64th up to about a 1/4 inch. So let's talk a little bit about machining data and some tool life data. So we said that the WXL line can be recommended for non-ferrous materials, gummier materials, all the way through hardened steel. So here's an example of the WXL LNEDS list 3791. This is a 1mm diameter tool in copper, doing about 20,000 RPM, 34 inches a minute. And here we see what the depth of cut is 2 thou axial depth of cut versus a radial step over of 35 thousandths. We're using water soluble coolant here. So what you're seeing are the pictures of the tool wear after 4 hours of milling in this condition. So the top 3 pictures, end cut, margin, and rake face, the topmost picture is the WXL tool, whereas the bottom picture is the competitor tool. And what you see is the level of damage on the corner cutting edges for each tool with the same amount of milling done. And here's an example of Stavex with the WXL PCEBD. This is a radius 1 ball nose tool in Stavex. So Stavex is typically a hardened, it comes in a hardened state. It's like a 400 series mixed with a hardened steel. So in this case, we were milling at 10,000 RPM, almost 80 inches a minute, doing some contouring cuts, very light step overs and step downs, 2 thousandths on both the radial and axial depths of cut. So what you're looking at here is the damage to the cutting edges after about 240 meters or 787 feet of milling in this condition in this material. The list 3712 is the OSG tool up in the top left, whereas the other pictures are 3 of the competitors that we put up against the WXL. So what you're looking at is basically that center point. So once the center point no longer is there, the chisel has been completely eaten out because of the abrasion to the material. This tool is no longer going to hold its ball nose form. Your finish goes off and the tool is basically done. So you see in this case, the list 3712 WXL tool was the only tool in this case that actually survived and maintained its chisel edge throughout the whole test. So let's move on now to the WXS end mill series. So the WXS and the WXL kind of go hand in hand. They're like brother-sister series, if you will. The WXS tools are like the WXL in the sense that they are named after the coating that's on them. So we'll talk about just the slight differences between the series here, but starting with some of the features and benefits. High surface hardness, high oxidation temperature, and that's again coming from the substrate and the coating that's on it. And these tools are specifically meant for hard and tough materials up to 65 Rockwell. And it also, like the WXL, has a pretty large offering as far as different types of styles of end mills to choose from. So this should look familiar to you. This was the slide that I presented in the WXL section. Now with the WXS, I said they kind of go hand in hand. So this is the material range that we'd recommend for the WXL, from aluminum up to hardened steels, 45, 55 Rockwell. The WXS kind of overlaps a little bit with the WXL in the mid-range hardness materials, but then extends itself up to 60, 65 Rockwell material. So that's primarily where the WXS is going to fit in for you, is for harder material. Now talking about the WXS coating, as I said before, the tools are named after this coating. So it's a series of tools that's named after the WXS coating, and you can see a comparison of the WXS coating to the WXL, which we already talked about, as well as the EXO, which is the TiALN based coating we also talked about. So the WXS coating is over the WXL is even harder, and it's even higher in oxidation temperature. It's not as lubricative as the WXL tool, but for the application that we're recommending it for, it doesn't necessarily have to be. As I said before, we are recommending this for high materials, so it's more critical that the coating itself be harder and the oxidation temperature be higher. This slide also be Familiar to you as well, you see where the WXL lies, and this is where the WXS is. So you kind of get a side-by-side comparison of the various coatings that we offer. This is an interesting test that OSG did. So what OSG did is it took the WXS coated tool, one of them, and took 3 competitor tools of similar applicability, and they took all 4 tools, threw them in an oven at 1,000 degrees Celsius or 1832 degrees Fahrenheit for 15 minutes, pulled them out and just looked at what the coating and what the tools looked like after being heated at such an elevated temperature for so long. So here is the result of that test, and the results were pretty significant, pretty interesting to see. Not that I would throw any of these tools back into a spindle to start machining again, but you can clearly see which tools had the best success as far as resisting that high level of heat for that amount of time. And that's the power of the WXS coating. When you're milling hard materials, you are generating lots and lots and lots of heat. So having a coating that can withstand all of that heat and all of that damage because of how hard the material is really going to benefit you in the long run with your tool life. So now I'd like to get into the different varieties of products that you can see from the WXS series. And as you can see from this slide, there's quite a good variety of them to choose from. So let's highlight product number 1. So one of the end mills types that you can get out of the WXS series is the WXS EMS, list 4440 and 4540. And I can say that this is actually our highest selling premium end mill currently. So this tool is a square end tool, multi-flutes as you see. It's got a very nice milling tolerance to it, so it can be used for roughing all the way up to finishing. It's just a very versatile tool for high hardened material. And this is a piece of cutting data regarding the WXS EMS in D2 tool steel 60 Rockwell. It's a 10 millimeter size tool, 4,800 RPM, so we're broaching up to 500 surface foot with this tool. 34 inches a minute, so that's a thou per tooth. Doing some side milling, 393 thousandths on the axial depth of cut, 20 thousandths on the radial step over, and what you see is the milling length versus these 2 competitors and how much flank wear or how much cutting edge wear there was after that amount of milling. So as you see, all 3 tools lasted roughly 17 meters in length. However, when they pulled the tools and looked at how much damage was done to the cutting edge, you see that the WXS EMS in the red had half that amount of wear on the tool versus the other 2 competitors. And continuing on from that piece of data, looking at physically looking at the tool here in these pictures, what the WXS EMS tool looked like on the cutting edge versus those other 2 competitors after 660 linear inches. So this is a really interesting demo that we usually perform in live at our facility in Illinois. We call it the lights out demo. So this is the OSG WXS EMS tool versus one of the competitors that we have, and it's in D2 tool steel 62 Rockwell, 515 SFM, so it's 5,000 RPM and 105 inches a minute. So we're just doing side milling passes, one after the other after the other. So we're doing multiple passes of side milling at 400 thou step down and a 10,000 radial step over. And what we do is we shut all the lights off and we just let this program run, first with the competitor tool, then with the WXS tool, to see the difference in how much glow we can see at the cutting edge. Because like I said, when we are cutting high hard materials, we're creating a lot of heat, and that heat you can see, especially when the chips get real hot and the cutting edge actually starts to glow red. So this is what it looks like. right, so the next highlight we're going to come to is the WXS EBD, list 4410 and 4510. So we talked about the WXL EBD as one of the highlights, and it was highlighted then because of the radius tolerance that we're able to achieve on the radius. So this tool, the WXS EBD, is that same tool with respect to the tolerance we grind on the radius, but that's about it. So this is more for the hard materials, where the WXL EBD that I talked about before is for more of the softer stuff. So if you need that same quality of precision and that same quality of accuracy and finish from your ball nose tool, but you're in a harder material, this tool is going to be the tool to go to. And here's just a data set of that same tool, the WXS EBD Radius 1 in D262 Rockwell, 32,000 RPM. So this is high-speed machining here, 824 SFM, 110 inches a minute, doing some pocketing and some pocketing work with an axial depth of cut of 1 thou 5/10 and a radial step over of 2 thousandths. So looking at the number of pockets this time, not necessarily the linear inches, it was able to achieve, but the number of pockets in this case. So you see that the WXS EBD as well as competitor B were able to get 5 pockets, whereas competitor A was only able to achieve 3 pockets. But taking a look again at the flank wear or the cutting edge wear at the time that the tools were pulled out, you can see that the WXS EBD had the least amount of cutting wear with the most amount of tool life on it. So looking at these pictures, this is just continued from the previous slide, you can see not only what the tools looked like in real life and how much damage there was at that center chisel point, but also what the ball nose form looked like as well with respect to the damage that's done to it. So you can see from that profile how much damage to the center point truly affects the overall accuracy of the radius. So I said this before with the WXL EBD, once that piece of the tool has been worn out, you no longer can achieve the same quality finish and you have to replace the tool. All right, looking at the last product highlight for the WXS series, here we're going to be looking at the high feed bull nose end mills. We've got 2 series of the bull nose tools, and when I'm talking about bull nose, so as you can see, this is a huge corner radius. So a bull nose tool is basically a corner radius tool, but the corner radius makes up a significant chunk of the diameter of the tool, if that makes sense. And it's used not the same way a traditional corner radius tool is used. It's used for high feed machining. So like I said, we have 2 different styles of the bull nose tool. We have this WXCRE list 4470 and 4570. And we also have the WXS CRE, which is list 4472 and 4572. The difference here being that the first tool, the WXCRE tool, is a 4-flute with basically a straight helix angle. It's a little bit more rigid. The WXS CRE, which you're looking at right now, has a spiral helix to it, a spiral gash to it, and it's 5 flutes instead of 4. Note it's also non-center cutting, whereas the previous tool was center cutting because it was 4 flutes. The main difference here is, one, because it's got a helix to it, it's a little sharper. So we recommend this tool more for some of the gummier hard steels or some of the gummier materials in general, because it's got a little more of a sharp cutting edge to it. So the concept behind high feed machining or high feed milling is chip thinning. So that may be familiar a term to some of you, maybe not, but basically it is a ratio of the programmed chip thickness versus the thickness of the chip that you're actually cutting because of how deep your axial depth of cut is. So in the case of a bull nose tool or any type of high feed cutting tool, your axial depth of cut is going to be very, very shallow. In fact, it's only going to be a percentage of the full radius of the tool. So, you know, if you've got a 3 mm radius on a particular bullnose high feed cutter, your recommended axial depth will only be maybe a couple percent of the radius of the tool as your axial depth of cut. So you're never actually going to take an axial depth of cut that is equal to or greater than the radius of the tool itself. And because you're taking very shallow depths of cut, the actual chip thickness that you're going to be pulling off of the material is thinner than what your programmed feed rate is going to be. And that's what's called chip thinning. And that for that reason, because your actual chip load is not what your programmed chip load is, it's actually smaller, you can program a heavier chip load with the tool and still run okay without chipping anything out. So this is one test data set kind of showing the advantage of a high feed bullnose type cutter with respect to pocketing in this case. So we compared the surface finish and the cycle time of a ball nose tool, and then also compared the surface finish and the cycle time with the same size pocket but with a bullnose style tool with a high feed mill. So in the first test, we wanted to get as best of a cutting time as we could. So we want to get a really low best cycle time as we could with not really caring about the surface finish in the end. And this is with a 2-flute ball nose tool. So here we're able to achieve about 17 minutes to cut this pocket out and found that the surface roughness was about 44 RY. Now we flip-flopped that in the next one and said, okay, well, we don't care about cutting time as much, but we want to get a really pristine, as good of a surface finish as we can. So naturally, the cycle time went up because we had to bring our step downs lower to get a better surface roughness. So in this case, we had gotten the surface roughness down to about 20 RY, but we almost doubled the cycle time. Now we did that same pocket with a high feed cutter with the WXCRE, and what we found is that because a bullnose cutter can take such a bigger step over versus a ball nose tool, it cuts the cycle time down dramatically, and as long as you're machining a flat floor, the surface finish will be flat because this is a flat bottom tool. It's got a huge radius to it, but ultimately it's still a flat bottom tool. So the surface finish in this case, the surface roughness was the best, and the cycle time was also the best with the WXCRE tool, with the high feed tool versus the 2-flute ball nose tool. So that's the advantage of one of the advantages of having a high feed bullnose cutter tool versus finishing or trying to high speed machine with a ball nose tool. An additional benefit of the high feed cutters is that there is no long length of cut because the recommended axial depth of cut is so shallow, you don't need to have a long length of cut with these tools. It's got an extended long neck so you can still reach deeper into pockets, but it doesn't have a long length of cut as you see in the picture on the lower left hand side of your screen. So therefore, when you do get deeper into the pockets, you're not rubbing along the sidewall as much, you're not generating as much chatter and vibration. So it's more stable of a milling operation, and you can better control some of those chirping and chatter marks you see when you turn corners. So we pretty much hit all of the tools in the WXS series. Just to recap, we've got square, ball, nose, rib cutters, and corner radius tools, and we're just going to talk about the different lists of each type. So the WXS EMS tools, we've got inch and metric, and those are squared, are go-to square and end mills. So 16th up to 3/4 and a mill up to 12 mil for these guys. For the corner radius tools, we have 7 different list numbers. a couple different styles, some a reduced neck, some a little bit longer or shorter, with a varying amount of diameter size range offerings, somewhere in the ballpark of a 1/16 up to roughly a 1/2 inch with metric equivalents. For the ball nose tools, we did add 2 new series of the ball nose tools here, but as you can see, we've got a pretty wide variety to choose from. We've got 2 flute regular ball nose end mills, all the way up to a 4 flute, a true 4 flute where all teeth come to center, as well as a spherical type or kind of a lollipop type cutter as well. And lastly, we have our rib processors, 3 lists of rib processors here, one of them being the kind of taper angled rib cutter. We've got some square end type rib processors, as well as a ball nose rib processing tool. And that will conclude this section of the OSG WXL and WXS end mills. Again, my name is Alyssa Walther, OSG product engineer, and you have a great day.